Hey everyone, so today we're going to determine whether an xy coordinate is a solution to a system of equations or not. Let's take this first example. And as you see here in step 1, substitute the x, y coordinate values into each equation. So that's what we're starting with, that step. Let's take our x, y values, which we need to identify here. So the 8 is our x value that's given, is 8, 3, and the 3 is the y value, is 8, 3 a solution of the system? We want to know, are these x and y values going to make these equations true? So we want to substitute, as it said here, substitute the x, y coordinate values into each equation. I'm going to start by rewriting the first equation right here. That is negative 8 plus 4. And then the y value is, in this case, and then the y value, which is 3, equals 4. So I've copied the equation, substituting 8 for the x and 3 for the y. Notice I put the 3 in parentheses because it's next to a 4, next to a coefficient. So this tells us we're going to need to multiply those two numbers. So now just simplify following the order of operations, as we're told here in step 2. Simplify the equations and determine if the statement is true. So let's go ahead and simplify. That is 4 times 3, which is 12. We bring down our negative 8. This is a positive 12. Bring down our 4. Now we're ready to go ahead and add. So if we go ahead and add, we're taking 8, or negative 8 rather, plus 12, combining those. Negative 8 plus 12, or if you think of it backwards, positive 12 minus 8, that is 4. Remember, if you need to double check your addition, subtraction, especially with integers, those positive and negative values, use your calculator. We bring down the 4 on the other side, and look at this. They check out, meaning 4 is equal to 4 is a true statement. So yes, this is true. Now let's repeat this process for the second equation. If the second equation also happens to be true, then we will be able to select the option of yes. So let's go ahead and plug in our x value of 8 here. And then that is plus 3 for the second equation, plus 3. And the y value this time is, again, 3, followed by equals 1 this time. So let's go ahead and, as step 2 tells us, simplify the equations and determine if the statement is true. So follow the same steps to simplify. Let's multiply 3 by 3, and that gives us 9. Bring down this negative 8 plus that positive 9 equals 1. Let's continue to simplify by adding negative 8 to positive 9. Negative 8 plus positive 9 does give us a positive 1. And that is equal to 1. Yes, it is. So we have two true statements, meaning that, as step 3 says, if both statements are true, then the xy coordinate is a solution to the system of equations. So therefore, in this problem, our solution is true. So we would go ahead and select the option yes. Now let's try the second example. If we take the equation y equals negative 4x plus 6 and try to figure out whether or not the ordered pair 2, comma 2, in other words, the x value is 2 and the y value is 2, is a solution to the system. So let's go ahead and substitute the y value first, which is 2, equals negative 4, followed by this x value of 2, followed by the plus 6. And let's go ahead and now simplify, like in the first example. Negative 4 times 2, that is negative 8. And let's go ahead and bring everything else down. Bring down the 2 on the left side of the equal sign. Bring down this plus 6. And let's go ahead and continue simplifying. So negative 8 plus 6. This is negative 2. Bring down the equal sign. The 2 Is 2 equal to -2? No, it is not. So because the first equation is already not a true statement, or with this ordered pair 2, 2, then we can automatically go ahead and select this option of no. There's no need to even test the second equation, even if it happens to be true. Because the first one was not true, we can already make the conclusion that this is not a solution. Because remember, step 3 says we must have both statements as true in order for the ordered pair to be a solution. So that is how you check whether or not an ordered pair is a solution to a system of equations.